Next is binomial distribution. Binomial distribution describes or answers the question of number of successes in n trials. So if we flip a coin 10 times, what is the probability of 3 heads? That sort of answer we can get by binomial distribution. So example, in we flipping a coin 10 times, and x is the number of heads. So the possible number of heads will be from 0 to 10. Now if we create a probability distribution for this, and this is the number of trials, you can get a head, and suppose we are looking for x is equal to 3 or 3 heads. So you can get 3 heads and the rest will be tails. So in how many ways I can choose the 3 slots here out of 10? That will be 10 choose 3. That now what is a probability of one such combination from occurring? That each of these has a probability of half. So one such combination, because even T and H they both are equal half, it will be 1 by 2 times 10. So the probability of x is equal to 3 will be 10 choose 3 and half times 10. But what if the probability of H is not equal to probability of the T? For example, a disease affects 10% of the population. If I pick a random person, chance that the person have the disease is 1 by 10 or 0.1, and picking person without the disease is 0.9. So this is just like flipping a coin which is biased. So now probability of head is 0.1 and probability of tail is 0.9. Now we can consider the same 10 causes of a coin. Probability of head in any toss is going to be P, and probability of tail is 1 minus P. It's not just P, because P is not half anymore. P can be any number. Now again, with the same principle above, the probability of x is equal to 3, the combination is still going to be 10 choose 3. But now if we calculate the probability of each of this sequence of runs, the probability of H is the successes, which will have the probability of P, and if we running them 3 times, it will be P times 3, while the probability of failures, which are the T's, are 1 minus P, and we are running them 7 times. If we or it's running it 10 minus x times. So the binomial formula becomes, if N is the number of tosses, P is the probability of head in any toss, X is the number of heads, then the binomial formula is probability X is equal to little x is N over X, P X 1 minus P N minus X. And this is also the probability mass function, or f of x is equal to the probability mass function for a binomial distribution, that is also this. And since this is probability, the sigma f of x is going to be 1. The next is, what is the expected value of a binomial random variable? So if we roll a dice, we can get 1, 2, 3, 4, 5, 6, each with a probability of 1 over 6. I want to know, if I roll a dice, what is the expected value of x. If I roll a die, I get a number x1. If I roll a die, next time I roll a number x2, next time I go to number x3. So what a binomial random variable would be, the expected value of x is the weighted average of the possible values of x, which are these. Each value is weighted by the probability that x assumes it. So the value of x is 1, and the probability that x assumes that value is 1 by 6, plus average value of x is 2, and the probability is 1 by 6, plus 3 times 1 by 6, plus 4 times 1 by 6, plus 5 times 1 by 6, plus 6 times 1 by 6, or we can take 1 by 6 out and it becomes 1 plus 2 plus 2, 6. This comes out to be 3.5. So in essence, what it becomes is n times p, where p is the probability and n is the expected value of x, becomes n by p. And this is also very intuitive. For example, we have, if the probability of head is 0.3 and we do 100 tosses, or probability of head, how many heads you will get? You will get 100 times 0.3, that is equal to 30. Some other very useful principles in binomial random variable is, say we did 3 rolls of a die. Each roll you get a number x1, x2 and x3, and say y is equal to x1 plus x2 plus x3. Then I want to calculate the expected value of y. So expected value of y is nothing but expected value of x1 plus expected value of x2 plus expected value of x3. Since we know the expected value of each roll of a die is 3.5, the expected value of 3 rolls of a die is going to be 3.5 times 3, or 10.5. So some of the questions that can be answered by the binomial equations are, a coin is flipped 100 times. What is the probability that head comes up 60 times? If you buy a certain type of lottery ticket once a week for 4 weeks, what is the probability that you will win a cash prize exactly twice? So number of wins in n Bernoulli trials is the binomial distribution. So question, a balanced die is rolled 3 times. What is the probability that 5 comes up exactly twice? So now 5 is the success. Here x is equal to 2, n is equal to 3, and probability of 5 is still 1 by 6. So 3 choose 2 will be your, this is also called as binomial coefficient, and then 1 by 6 is twice, and 5 by 6, which is 1 minus 1 by 6, is 1. That gives you 5 by 72. So this area here, this is called as binomial coefficient. Now another question is a probability of a 90-year-old male, 90-year-old male surviving another year is 0.82. If 20 90-year-old males are randomly selected, what is probability exactly 18 survive for another year? So if you think of this as a Bernoulli random distribution, because what we are looking for is a success, which is the survival. So n here is 20, x is 18, and probability is 0.82. 18 successes out of 20. 20 Bernoulli trials we are doing, and probability of success of each trial is 0.82, and there are x number of successes we are looking for. So probability of x is equal to 18 is 20, choose 18, 0.82 times 18, and 1 minus 0.82 times 2. The other question would be, what is the expected value? So expected value mu is equal to n times p, which was 20 times 0.82, which is 16.4. So the way to describe this is, on average 16.4 of 20 males will survive another year. And what is a variance? So this is another formula for variance in binomial random variation is np 1 minus p. So that will be 20 times 0.82 times 0.18, that is equal to 2.952, and standard deviation will be under root 2.952. Now this is easy because we want exactly 18 to survive for another year. But if we want to change the question to at least 18 survive for another year, then you have to calculate the probability of each of them separately, 18, 19 and 20, and then add them. together.